For this video, I'm going to go through an example of calculating a tension in a cable by summing the torques and summing the forces. So you can imagine I have this picture here, and there's a beam that's against a wall and that's held on by this cable. Let's just say that this cable makes an angle here of 53 degrees. And this beam is 5 meters long. And let's say that this man is standing at a distance of 1.5 meters. Okay, so the question is, what is the tension in the cable? Okay, so from this, I can automatically say, all right, well, this is in equilibrium. So I know two things. I know that the sum of my forces are going to be equal to 0. The sum of the forces in the y direction are equal to 0, and the sum of the forces in the x direction are equal to 0. That might be helpful. The other thing I know, this is in rotational equilibrium, so it's not rotating and it's not accelerating. So the sum of the torques are going to be equal to 0. These two things are going to be important. Before we can really move forward, though, like I don't know what to do. And so I am thinking, all right, well, maybe we need to draw a free body diagram. And so now our free body diagrams are not just a dot. Remember, they are the whole object. So I'm going to draw mine over here nice and big. What are the forces that are acting on this beam? The easy forces to mention are going to be the force of the person. So here we have the force of gravity due to the person. The force of gravity due to the beam will always act at the center of mass. Force of gravity always acts at the center of mass of an object. So we get this force of gravity due to the beam. And then one more easily found force is this force of tension that goes this way, acting at an angle of 53 degrees. If these were the only forces acting on this beam, I can look at this and I can say, well, the sum of my forces in the x direction don't look like they're going to be equal. This looks like it's going to be accelerating to the left. So I need another force in there, and that's actually going to be a force due to the wall on the object. And I always draw this force at an angle. You don't know what the y component is going to be, whether it's positive, whether it's negative. So it all depends on the tension. It all depends on the force of gravities. So I'm just going to go ahead and draw that here. And I'm going to call that the force of the wall. All right. So first steps, I can sum my forces. I can sum the forces in the y direction. I can sum the forces in the x direction. But since we're in the torque unit, I'm gonna sum the torques first. So the first thing I'm going to do is sum my torques. Now it's very, very, very hard to sum the torque if you don't know where your axis of rotation is, right? Because the torque is the force times the lever arm times the angle between them. And so if I don't know what my axis of rotation is, then I can't find the torque. And so we have to determine like where that is. Now, the little trick that we have to figuring out where that axis of rotation is to put it where we don't know a force. If you don't know a force, if you put that axis of rotation at the same location as that unknown force, then you won't have any torque due to that force because you don't have any radius between it. I'm looking for the force of tension. I know the weight of the beam, or I'll write it down later. I know the mass of the person. And so if I put my axis of rotation here at the end, I'm just going to call that 0. Axis of rotation, then I don't have any torque due to the wall, the force by the wall. So I sum my torques. The sum of my torques will be equal to 0. And now I can start talking about whether the torque is positive or whether it's negative. So again, the torque due to the wall is going to be 0 because there is no lever arm. There's no radius. Then we can add in the force of gravity, the torque done by the person. That's going to be in the downward direction or the clockwise direction. So it's going to be negative, the torque due to the person. And the torque due to the beam is also going to be negative. And then we'll add in the torque of the cable, the torque of tension. All right. At this point, we would need to know so at this point, we can just use our torque equation. 0 equals the force of gravity on the person times the radius of the person, cosine theta. In all of these cases, this cosine of theta is 90 degrees, so that goes to 1. So I'm just not going to write it for the rest of them. The force of gravity above the beam times the radius of the beam. I'm just going to call it RB. Plus the force of tension times the radius of the tension. All right, when I look at this again, I know from my picture that my person's radius is 1.5 meters. The length of the beam is 5 meters. And so that means half the length of the beam where the force of gravity acts will be 2.5 meters. So I can put those in there. And let's just go ahead and give some values for the person and the beam. So let's say that the weight of the person is 600 newtons and the weight of the beam, let's make it lighter, is 300 newtons. All right. So here I get 600 newtons negative times 1.5 meters minus 300 newtons times 2.5 meters plus whatever that force of tension is times the radius, which is 5 meters. When I do the math on this, then I will get the force of tension, just multiply and then add over and divide. The force of tension is going to be 413 newtons. It's at this point that if somebody really wanted to know, like the second part of this problem was what are the X and Y components of the force of tension, it's at this point that we can sum the forces in the X direction and sum the forces in the Y direction. So you know that the sum of the forces in the X direction have to be equal to 0, which means that the force of tension in the X direction is equal and opposite to the force of tension, or the force on the wall in the X direction. So you could solve this out, and then you could say, okay, we'll sum the forces in the Y direction, and then you can find the Y component of this force, and then you could find the angle if you wanted to.